Hey, what's up, guys? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man, here in Soldotna, Alaska at Talon Air. About to get on the float plane back there. Gonna fly a little ways away, go over close to Lake Clark National Park, head up Wolverine Creek, and hopefully see some brown bears feeding on some salmon. So it's gonna be a pretty nice day. As we're flying, I was kind of thinking about the atmosphere and the composition of it. Our atmosphere's got, all the gases we need for life on Earth. We got 78% nitrogen and 21% oxygen and some other trace gases like argon and carbon dioxide. So those gases are all matter. They're made up of atoms. Each of them has a little bit of mass to it, and that's what actually helps a plane to fly. Something called Bernoulli's Principle. So as the plane is moving through the air, it's got different forces working on it. The engine propels the plane forward. That's the force of thrust. And as it's flying through the air, it's bumping into all those molecules we just talked about. And every time it bumps into a molecule, it actually slows the plane down just a teeny little bit. And that's called the force of drag. So you got thrust pushing forward and drag pulling backwards. But then you also have forces going up and down. The most significant of which is gravity pulling it down. So you got weight as that force there pulling it down. So you need a force to be able to keep the plane up in the air, and that force is lift. So lift is created when there's a difference in pressure in the air. I don't know if you can see it on the wings on the plane back here, but the wings aren't perfectly flat and straight. The wings are curved on the top, and they intend to be more straight on the bottom. And as it cuts through the air molecules from the front of the wing to the back of the wing takes the exact same amount of time for the wing to pass through that air. So if it's the exact same amount of time, but we have a curve on the top, it takes longer, the molecules have to go faster to get across the top of the wing than the bottom of the wing. And that difference in speed of those molecules creates a difference in air pressure. And the pressure in air, the air always wants to move from areas of higher pressure to areas of lower pressure. So if the molecules are moving faster along the top, we've got lower pressure up there and higher pressure underneath where they can go a little bit slower to get to the same point. And so the air below the wing wants to try to get above the wing, and it's going to start to push up on that wing. And that produces that force of lift, which is so important for a plane to stay up in the air. Pretty cool aerodynamics there. I just want to share that with you. We're about to get on our plane and hopefully see some brown bears. I'm super excited. Just want to share that with you and tell you that science rocks. Peace.